So on this problem, they want us to find the exact values of these trig ratios using this diagram over here on the right. Now, my diagram has some points labeled. If yours doesn't have the points labeled, you need to go back to the slide before and label those points. And there should be a video a couple slides before that that shows you how to do it if you're stuck. But these labels on these points are really important because they tell me how far over and how far up the point is from the origin. And so without that information, this would be really tricky to do. So let's go ahead and do this first one. We want to find the exact value of the sine of pi sixth. So first let's figure out what angle that would be. So pi sixth, remember pi radians would be 180 degrees. So this is pi radians right here. And pi 6 would be 1/6 of that. So notice this is chopped into 6 equal chunks here. So pi 6 would actually be this angle right here. So we want to find the sine ratio of this angle. That's going to be this distance here, which I'll call y, divided by this distance here, which I'll call r. So what is y and r? R is easy. We know that that equals 1 because they told us that the radius of the wheel was 1 meter. So my r is 1. And the y value is going to be the y coordinate of this point. So this point, remember, is telling me that I went over this far and up this far to get to that point. So y equals 1/2. And like I said, there's a video a couple slides before this that shows you how we figure that out. But once I know that that equals 1/2, then I can come up here and I can write my ratio as 1/2 divided by 1. Now dividing by 1 isn't going to change this. It's still going to be 1/2. So the sine of pi sixth is equal to 1/2. All right, let's do the sine of 5 pi sixth. So if this angle here is 1 pi sixth, this would be 2 pi sixth, 3 pi sixth, 4 pi sixth, and 5 pi sixth would be this angle here. So I'm going to want to find the sine ratio of this angle right here. And to do that, I'm going to take this side, which we'll call y again, and divide it by this side, which we'll call the radius. And again, I know the radius is 1 because they told us the radius of the wheel is 1 meter, and that's going to be true for every direction. And I know the y value by looking at the coordinate of this point. So it looks like it's going up 1/2. So this distance is 1/2. So again, I'm going to have 1/2 divided by 1, which is just going to equal 1/2. Now, just for fun, you can type those into your calculator and you'll see that the output is 0.5, which is another way of writing 1/2. So the sine of 5 pi 6 and the sine of 1 pi 6 are both equal to 1/2 exactly. Now the cosine of 7 pi 6, we left off with 5 pi 6 here. 6 pi 6 would be halfway around the circle. 7 pi 6 would be right here. So I want to find the cosine of this angle here. And the cosine, remember, is going to be this length here, which we'll call x, divided by this length here, which we'll call r. And r is 1. The x value here is how far over I've gone to get to this point, and I can see it right here, that it's negative square root of 3 over 2. So this distance here is the negative square root of 3 over 2. So my cosine ratio is going to be that, negative square root of 3 over 2, divided by 1, and that's just going to equal the negative square root of 3 over 2. Now, if you type cosine of 7 pi 6 in your calculator, you'll get that it's equal to this, negative 0.866025, and that just keeps going. That is not exact, though, because this decimal actually goes forever without repeating, so we had to round it to write this down. If we want an exact value, we would write this negative square root of 3 over 2. So up here, because the decimal ended, those are exact. A decimal that never ends isn't exact because you can't finish writing it. You have to round it eventually. Now also notice with this that with every single one of these, I was dividing by 1. That's because the radius of this wheel is 1 in every direction. So this is a unit circle having a radius of 1. And that makes it really easy to see what the sine, cosine, and tangent of any angle is because it's just going to be the x and y coordinates of the points themselves. So the unit circle is special because of that.